morning, pilot teachers and students. Good morning, class.
Good morning, sir.
Okay, thank you. You may sit down. All right, quickly to recap on the last lesson. All right, there is a difference between mass and weight. All right, our weight is simply when the force of gravity has to act on that object, and the mass is simply the amount of matter that is contained in that object. Now, in this lesson, I will be going through a topic which are on scalars and vectors. Right, the first question is, what is a scalar and what is a vector quantity? Now, you have seen that in a lesson from last term, you studied the different types of quantities, and then you found out that these quantities can be either derived or basic quantities. Now, there is also another method of classifying these quantities, and those two methods are the scalar and vector quantity. Now, looking at the first one, which is the scalar quantity, what is it? Now, simply, a scalar quantity is a quantity that has only size, but it does not have any direction. Okay, that is a scalar quantity. And a vector quantity is a quantity that has both size and direction. For example, displacement is a vector quantity because it has the size and direction. Speed is not a vector. But if you have to look at displacement, displacement is a vector quantity. Velocity is also a vector. Speed is not a vector quantity. It is a scalar quantity. Okay, what I'd like you to do now is to quickly go through, copy this information. I will show you two examples of vectors and how you can add those vectors. After that, I will be asking you to go through this activity. I have some activities on the board here for you. Okay, that is after you have copied this information. Okay, quickly go through. Pilot students, you can go through now and then have these notes down into your exercise book. If you have finished, you can sit up straight so that I can see who is finished. Okay, I will go to the next information. Okay, those are some examples of scalar and vector quantities. Okay, for this one, the length is a scalar quantity. It does not tell you the direction. Displacement is a vector because it tells you of the direction as well. Speed has a magnitude. It has a unit, but it does not tell you of the direction in which the speed is going. Right, looking at velocity, you may be thinking that this speed and velocity are the same things, right? If you have to consider speed, speed is a distance over the time, while velocity is a displacement over time. Okay, time is not a vector, but it is a scalar quantity. Acceleration is a vector, tells you of the size and direction. Volume is not a vector, it is a scalar. Right, force is a vector. So quickly go through, have this information. I'll give you next part of the information on this table here. All right, I will now go on to the next. You finished? Quickly have this information done. I will quickly explain to you those. Okay, if you can look up, I'll quickly go through and then give you. Okay, the mass, for example, is a scalar. All of this coming down are scalar quantities. And then you have the weight, the momentum, the torque, as well as moment, electric current, electric field, and magnetic flux density is also under vector quantities, meaning that they have both size and direction, while these quantities don't have size and direction. Okay, now to the representation of a vector. Right, a vector can be represented by an arrow. The length of the arrow represents the magnitude, and the direction of the arrow shows the direction of the vector. Right, if you can watch carefully, for example, if I have to have, okay, this is 1, 2, okay, this is, okay, 1, 2, 3, 4, and 5. Okay, this is 4 newtons that is applied to move this box here. Okay, we have to apply the next, let's say 4. 2 of these 4 newtons are acting in one direction. So we can simply say that that is 4 newtons plus, okay, 4 newtons. Sometimes you'll find that there is a symbol which shows you the direction of the vector, just about that. So in here, 4 newtons is applied to that plus another 4 newtons. So you're likely to have a resultant which is around about 8 . Okay, about 8 newtons to the right. So that is simply what is known as this representation of vectors. Right, what I'll do is quickly go through, I'll explain 2 examples and then you can go through this activity. Finish. Finished. Okay, good. Everybody should be finished with that. Okay, I'll show you 2 examples. All right, we'll have a look at 2 examples here. Okay, velocity is also a vector quantity because it tells you of the size or the magnitude and the direction. Right here, 2 examples to show you on these scalars and vectors. Right, let's have a look at the first one. Okay, example 1, you have the velocity of the plane plus the velocity of the wind, and the resultant velocity of the wind will be in that direction. Okay, now look at this one. Okay, let's say this is about 4, or let's say if this is 2 meters per second for the velocity of the plane. And then if you have the velocity of the wind, let's say, in other words, the wind is also supporting that plane to travel. Okay, that is the velocity, another 2 meters per second for the velocity of the wind. Okay, the resultant will be, okay, good, it will be 4 meters per second. Now, have a look at this again. Okay, this is the velocity of the plane, and then you have the velocity of the wind. Okay, the resultant velocity of the plane will be 4 meters per second to the left. Okay, now on to the next example, right? This time a force. Okay, let's see if this is a block of metal, right? If, let's say, 4 newtons is applied in that direction, okay? Right, this is 4 newtons and it is applied on this box. Okay, if another 2 was applied on the, or in the opposite direction, okay, this is 2. Okay, what would be the resultant of the force? 2 newtons to the, okay, to the left. 2 newtons to the left. All right, you find that this 4 is in the opposite direction with these 2 newtons. That is why we have to have 4 newtons to the left. Right, what I'd like to do now is to quickly go through, solve this example, but before you go on to those 2, there is an explanation which I will do before you continue with these exercises or the activities. All right, give an example, like if you apply 4 newtons to, let's say this is a block of wood or a box, right? A 5 newton is applied that way. These forces are not parallel. In other words, they are at 90 degrees. So in this case, we can use the Pythagoras theorem to find the resultant of the force. Now, before you do that, you draw in a diagram to represent, right? You have 4 coming down that way, right? The arrows should be joined head to tail. That is 4 newtons, that is 5. Okay, 5 is moving out that way, then you have 4 newtons. So if you find the resultant, it will be 6.4. Resultant of this force will be F1 squared plus F2 squared, which is equals to 5 squared plus 4 squared. Then you have 25 plus 16, which is 41, and the square root of that will be 6.4. Right, if you further want to find out the angle in which this force is acting, you can use, okay, tan theta to calculate the force, which is equals to opposite over the adjacent. Then you have 5 over 4, and the angle in which that force is acting is, okay, 51 degrees Celsius. All right, quickly go through. There's 6 activity questions shown here. Quickly go through and then solve those. Okay, you can also include. Okay, good. For the example there, you can include direction as well, in what direction that force is applied. Okay, you saw the resultant, the size is 6.4, the angle was 51.3 degrees. But and then you can say the direction. What is the direction? Right, if you don't know how to use a calculator to find the angle, my calculator is not new. Okay, that is an old model for FX82. So if you want to find it out, it is simply opposite over the adjacent, which is 5 divided by 5 divided by 4. That gives you 1.25. So using that, you press shift on the calculator and then 10. That will give you the You found the answer? You found it. See if okay. Question 5. You link to question number 5? Okay, you go for question number 5. Let me see. Malcolm, go for question number 2. Question number 3. You go for question 3. Samantha, question number 4. You are number 5. And last question. Who is willing to question number 5? Okay, Michael, go for question number 6. Sorry, question number 6. All right, finish that quickly. We'll go on to the correction of the questions. Okay, question number 1. Let's have the first person to come up and do question number 1. After you've gone through your working out, you can do your explanation. Okay. Okay, question number 1, quick. Question number 1. We'll have the first person to come up and show. Okay, just make a sketch of those information, that activity, right? It doesn't require you to go through and then draw nice diagrams. You can just make a sketch. Later on, you can write that neatly. All right, who was told to do question number 1? Come, let me check your. Okay, let's have question number 2. If question 1 is still working on question number 2. Okay, Malcolm, you come for question number 2. Yeah. Okay. No. You. Okay, 3 divided by 4, 3 divided by 4 equals.
Because there are 2 5 newtons, I add the 2 5 newtons, and because they are moving towards the right, I have 10 newtons to the right.
Right, good. The first one is for question number 2, 5 newtons from the left, and they will be moving towards the right. Okay, good. Question number 3.
Are pointing to the right, so I add both of them to, I end up with 6 newtons to the right.
Okay, good. So you have 2 newtons both acting on the same object towards the right, so it'll be 2 plus 4, and that will be 6 newtons to the right. Okay, moving on to question number 4. Quick.
When you go for question, this one, so how you got this one? You simply so proceed over. You explained 3 divided by 4. Okay, 3 divided by 4 equals to get this. You perceive where is 10. 10. Yes.
Okay, very good. For question number 4, you have 2 different forces. One is acting from the left, while the other one is trying to pull that from the right. So there is always a resultant, and the resultant of the forces should be towards the, or 2 newtons towards the right, because that right is much more greater than that force that is towards the left. Okay, the 5th and the 6th question. Okay, the 6th, get ready, 5th question.
To find the answer for number 5, it's the force is acting 3 newtons from the top and 4 newtons from the right. So to find that, I'm going to use the Pythagoras theorem, which is r squared equals to force 1 squared plus force 2 squared square rooted, which is equals to 3 squared plus 4 squared, which is 9 plus 16, it's 25. The square root of 25 is 5. So the force is 5 newtons.
Okay, so very good. The force, the resultant or the size is 5 newtons. The direction should be? Okay, if you have to look at that one, right, this is another force that is coming down. But then you have another one which is all moving that way. So, okay, first thing, remember to join the arrows or the force head to tail. In that way, you will be seeing the direction of the resultant. Right, now you see that one is going down that way, and then you have another one going. So the direction of the resultant will be this way. So it'll be 5 Newton. Okay, if this is not, that is east and west. So it'll be southwest. 5 Newton southwest at what is the angle in which this force is? Theta. If you want to find that angle, what is it? 50. Okay, it is about 36. Okay, 36. Okay, 36 degrees south west. Okay, your answer could have stated, explain something on the direction and also the angle in which this force is moving. The size of the force is 5 newtons as using Pythagoras theorem to calculate, and you come out with 5 newtons. However, if you want to calculate the direction in which this force is moving, the first thing is to consider joining these arrows or the head of the arrows head to tail. And then from there you can determine the direction of the force, and you have 36 degrees southwest. Okay, good. Last one. Okay, you can use the other side of the boat to do that. Quickly clean that.
Once again, to find the answer, to find the force, use Pythagoras theorem, and your answer will be 3.6 newtons. And then to find the direction that the force is moving in, you use 10x, which and opposite of adjacent, opposite is 2, adjacent is 3. You'll get your answer 0.66. Convert that times 10, and then you get your answer 3.6 newtons, 33 degrees. It will be moving 30 degrees southwest.
Okay, let's quickly go to the correction of this one. This is not 36, but this time it is. Okay, 53 degree. It is not 36, 53 southwest. Okay, moving on to the last one. Right, this is the force or the magnitude of the resultant. Right, if you want to calculate that, right, simply it'll be 2 over, so our 0.66 times 10 theta will give you 3.6 newtons, 33 degree. Is it southeast or north? Okay, should be northeast. Okay, this one is northeast, not south. Okay, why do we have northeast? Simply because, right, if this is 2 newtons, okay, you have 3 newtons, which is in that. So that means the resultant would be moving in that direction. So we have northeast. Okay, that is the those are the answers to the activity questions. We'll quickly go through a recap. Okay, representation of vector. A vector can be represented using an arrow. The length of this arrow shows you the size of that vector, and the arrow represents the direction of the vector. Okay, looking at some examples as stated earlier, you have this velocity of the wind and plane, and then you have the final velocity. Also for that one, you have 2 and 4. The resultant will be seen that. Right, that brings us to the end of our lesson. Okay, our keyword for today is simply on scalars and vectors. Once again, good afternoon, pilot teachers and students. Good afternoon, class. Okay, thank you.